Lavonni is a principal engineer at Wise. Wise is a company that facilitates international currency transfers for ordinary people, like for travel use cases and things like that. They're big Kafka users and big stream processing users, using a lot of Kafka Streams and some Flink. And Lavonni's going to tell us about how they work through the process of deciding whether to use one system or the other. Before we get to that, let me remind you that streaming audio is brought to you by Confluent Developer. That's developer.confluent.io. It's a website with everything you need to get started learning Kafka and Confluent Cloud. We've got interactive courses, video courses. There are executable tutorials, a library of stream processing patterns, index of episodes of this podcast, everything you need. When you do the interactive stuff, you get your hands on keyboard, as you need to do. You'll want to sign up for Confluent Cloud using the Podcast 100 code to get you an extra free $100 of usage credit. It's pretty cool. Check it out. But for now, let's get to today's conversation. Hello and welcome to another episode of Streaming Audio. I am your host, Tim Berglund, and you may notice I have a slightly different background. I'm in the middle of a month-long trip across Europe as a part of a series of events that we call our Data in Motion tour. By the time this airs, that will be in the past, but I'm coming to you from a hotel room in Frankfurt, not from my office as usual, but I'm delighted to speak today to Lavonni. Lavonni, welcome to the show.
Thanks, Tim. Thanks for having me.
You bet. And since I'm here, we get to speak at a nice early time. Normally, I'd be asleep now, but we have more of your day available to you. So we're going to talk a little bit about Kafka Streams and Flink today. That's really our subject. But I would love to start by hearing more about you and Wise, the company you work for. Tell us about Wise. Tell us about your role, how you came to be in that role. Tell us about Lavonni.
Yeah, sure. My name is Lavonni. I work at Wise for about 4 years now. And I've joined the company in the beginning as a into the fraud team, like fraud prevention team, not fraud.
Fraud prevention. There's always a distinction. Fraud team, there's the fraud prevention.
Yeah, exactly.
There's an old Dilbert joke about that. You must be thinking of the flu prevention darts. Anyway, yeah, fraud prevention.
Yeah. Exactly. But then I moved to the platform, and into the platform team, I was with my team. We were building the stream processing platform internally at Wise to help to scale our usage of our Kafka streams and our real-time aggregational queries. So Wise itself is a multi-currency account. So it's one of the biggest startups in Europe. Just last quarter, we moved around 18 billion pounds, and we have around 11 million customers. So this gives a bit of perspective of the scale that we have and how important it is for us to be competitive in this business. We have to be as fast as possible to transfer customers' money from one part of the world into another part of the world. And in this,
so the business is money transfer,
exactly.
particularly between currencies.
Yeah, and you can also, there is also a plastic card, so you have a Wise debit card, so you can use it in different currencies. So you can spend for example, you can have your money in USD, and when you go to US, you can spend the money in a local currency. When you go to Europe, you can spend it in a euro account. You can have euro account and spend money in euro. So we also have a debit card.
I feel like it would have been good for me if we would have had this conversation a month ago before I started my trip across half a dozen countries.
Probably. Kafka plays a very, very critical part in this whole money transfer, and nothing happens at Wise without having a Kafka event.
Oh, very nice. I like the sound of that. How did you come into this role? So what sort of background do you have?
When I joined the fraud team, the fraud prevention team, back then there was the scaling issues in terms of real-time queries and aggregations. As you can imagine, since we're a money transfer company, we also have to do all the compliance checks, make sure that the bad people don't use our platform for bad things. and fraud prevention is also one of the crucial part of it. And back then there were challenges of Wise was already was using the Kafka for event as an event bus, but we were still a bit more into the monolithic architecture. We already had microservices 4 years ago, but still we had big chunk of our business logic was living in a monolithic application. But since then we have gradually moved into the microservices, and now we have around 400 microservices working together.
Oh, wow.
And
are those all event? Would you describe them as reactive or event driven or whatever sort of word you'd want to use?
Yeah, I'd say most of them are event driven. So pretty much most of them emit some sort of events. We do have RPC calls through Envoy and through a service mesh. So that's also a very big part of this. But pretty much any background thing that doesn't have to be that users don't have to see on the web page, for example, or when they use the app, it's happening through events.
Nice. So, stream processing. You're Flink users, and you're also Kafka Streams users. So, kind of walk us through the evolution of that. How did you come into those technologies? And obviously, what we want to talk about eventually is how do you decide when to use one or the other? Because that's the thing that people think about.
So we are mostly Kafka Streams users. We've been Kafka Streams users for around 3 years now, a bit more than 3 years. So first we were ordinary Kafka broker, Kafka client users, and we were using Kafka as an event bus. But then Kafka Streams came, and when we started then there was a need of stream processing platform, and we decided to go with the Kafka Streams just because it was way easier to adopt than the Flink, because Flink is pretty much the whole clustering framework, while in the Kafka Streams you just have it as a library and you can build necessary tooling around it. So it was very appealing for us. We are mostly right now Kafka Streams users. We have around 300 stream processing jobs running based on the Kafka Streams, and we process a lot of data with this, and we store a lot of state as well. So in total, we have around maybe 50 terabytes worth of state, based on the Kafka Streams. So I think we are one of the biggest users of Kafka Streams that there are out there. As there are more use cases where where stream processing jobs have to store a lot of state, and in those cases we do see a benefit of Flink, mainly because one of the great advantages of the Kafka Streams is to have to store the change logs into the Kafka as a backup, right? But it's a bit of a weakness in a sense that we have to scale the Kafka brokers proportionally to how many stream processing jobs we have in order to scale the number of changelog topics and repartition topics we do have. So in the cases where there are some applications that have to store terabytes worth of state, the stream processing applications. So in those cases, just to ease the pressure on our Kafka cluster, we want to go with Flink in those cases. And also Flink has a few nice features that at the moment is missing from the Kafka Streams, like the save points. I guess that's one of the biggest one. So in the Kafka Streams right now, there is no way to roll back your state in a consistent manner to some point back, back in time, essentially. So if you produce the bug, you release new version of your stream processing job, and there is a bug, you have to, if the state gets corrupted, you have to pretty much wipe out your state and start from the beginning. In Flink, there is a notion of the save points, and in the save points, we can, for example, roll back your state to yesterday in a consistent manner. That's big. That's I think very big advantage in cases where we have to store a lot of state, and just replaying everything takes a lot of time. But we do prefer overall Kafka Streams just because it's way easier to maintain, and it's way easier to kind of integrate it in our overall stack that we have at Wise.
That's always encouraging to hear, because that's the thing everybody says, right? When you're thinking which one of these should I use? Well, Kafka Streams is a library, and you guys were already writing Java microservices. I assume Java, right?
Yes. Yep.
So, but certainly a JVM language, but it happens to be Java. And well, gee whiz, here's a library that gives you stream processing capabilities. So by default, that's the easier choice. You mentioned changelog topics and repartition topics. Now, I'm assuming everybody in the listening audience that you basically know what Kafka Streams is. I will try to link in the show notes to an introductory podcast or two. We have had, even recently, Bill Bejic has been on the show giving his overview of his Kafka Streams course that he wrote for Confluent developers. So if you need a refresher, we've got a course on Confluent developer, and we've got a recent podcast episode that kind of will take you through the basics. But what's a repartition topic? Assuming you know, audience, what Kafka Streams is.
So the repartition topic is essentially when you want to change the key. So for example, let's say we have a stream of transfers coming into our stream processing job, but now one of the payload of the one of the field in the payload of the stream of transfers, we have a profile, for example, and we have like number of transfers this profile has made. Now, if we want to aggregate the number of, let's say, if we want to sum all the invoice values that the profile has made in a given time, in that some time window, we have to repartition the stream based on the profile ID so that the data will be co-located into a single in specific thread. Essentially, this thread may be on another process, on another instance, or another JVM instance, or whatever. But the point is,
we'll call it another JVM.
Yeah. The point is to collocate the data. So if you want to aggregate based on certain key, you have to collocate the data, and repartitioning is the operation to select based on what you want to do, essentially stateful aggregations.
Basically, the way that has to happen is you have to create a new topic that has the new key.
Yep.
That reflects the grouping that you're going to want to do for the aggregation that you're computing next. And that's, I guess, generally you co-locate because you're going to want a group and because you're going to want to run an aggregation reducing function across the group. Is that generally the case?
Yes. Yeah. Essentially, that's the case. Yes. In the Kafka Streams, it also does in some cases, it does it very smartly. So it has optimizations in terms of like topologies. So it may group different. So for example, let's say you want to do different aggregations. So you have like different types of aggregations based on the same key. In the earlier versions of the Kafka Streams, it would create like as many repartition topics as many aggregations you have. But in the newer versions of the Kafka Streams, we have now the topology optimization, so that will group different aggregation, like repartition topics. It will create single repartition topics, and that repartition topic will be used for different aggregations if it's on the same key. So that's a very nice optimization.
Oh, yeah. No, that is, because it's not repartitioning is not the worst thing in the world. I mean, it's a thing you do in Kafka. Either you let Kafka Streams do it for you, or if you're writing your own consumers, I mean, it's a thing. So it's not like some kind of failure at life, but it does have a cost. You know, you have to move that data around and you have to store it again, and you know, those things actually happen. So it's nice to do it as little as possible, I suppose.
Yep.
Okay, and that repartition topics are a thing that get created upon the rekeying of an input stream, and changelog topics, which are the topics that back tables, right? So if you have a K table, you have to remember what's in the K table, and that's a changelog topic. And these things are stored anytime you've got state, or you have to repartition. It's like extra Kafka that you're using. Now, this is, and by the way, please feel free to disagree with me on this. I'm kind of expressing my opinion of the architectural decisions that Kafka Streams has made. Kafka, in every way possible, Kafka is built out of Kafka, right? Anytime you need to do a new thing, if there's existing pieces lying around, you take them and try to use them. Like, in Connect, when you have to remember input or source offsets or something like that. Well, you use a compacted topic. It uses an internal topic for that. So, if you need storage, well, you have, if you need distributed fault tolerant replicated storage, you've got some lying around. So you use Kafka, you make a topic. In Kafka Connect, when you have to rebalance workers between Connect or tasks between Connect workers, it's something a lot like the consumer group rebalance protocol, basically that repurposed. So you got Kafka pieces lying around. You make more Kafka out of that, and this is that. So now Kafka Streams needs various places to store kinds of internal state, and well, there's Kafka. So make more topics, and so the decision, the key, in my mind, key architectural opinion of Kafka Streams is it's a library. So it enhances your code with stream processing functionality, but stuff has to come along for the ride, and that stuff is extra compute. You're doing computation now in your application that you weren't, and extra storage, and with the combination of those two, you have extra I/O between your application and the cluster. And I guess what you're saying is, if I heard you correctly in the first real big question I asked, most of the time that works out in favor of Kafka Streams. It's like usually that's the thing that you want. And writing a job and deploying it to some other cluster where your compute happens isn't usually what you want. Yeah. But then sometimes it was. So tell us, tell us the story of how you got there. What did you bump into that made you think, wow, I really need a separate cluster for this?
There was a certain use case where one of our product teams, so just to explain a bit more about our platform, I think for the context. So we are we don't write the streaming jobs for others. We are enablers so product teams can write the stream processing jobs for themselves. So we don't take on business logic, but rather we try to bring libraries to the product teams at Wise, and technology and tooling and self-services, so the product engineers can do their jobs themselves. So we are very autonomous. So in a way that we don't dictate. We don't dictate what you have to use, but rather we try to build it in a way that, okay, this is already built and I don't want to do anything else. So just that's our philosophy. So the autonomous teams is very at the core of Wise engineering, and that's what enables us to scale. And based on that, since we can't since we have that many clients, we don't really have either capacity, or we don't really want to know exactly what each stream processing job does, but rather we want to trust product engineers that they will and they're doing their jobs they're doing their jobs based on whatever governance we will provide and whatever tooling we will provide. And one of the use cases that we had a while back was that there was a stream processing job that had to aggregate a lot of state, and by a lot I mean few terabytes. So it was pretty much consuming whole history of the TransferWise transactions. And when I say TransferWise, it's Wise because we just rebranded. So I may sometimes mix things up. So I'm sorry for that.
I understand. I happen to be wearing an on-brand shirt today. Sometimes I might have something on with the old logo. It just slips through. I totally get it. Anyway, Go on. Wise.
Wise.
Consuming the whole transaction history.
Yeah, because we have to build financial ledger or based on those things and all the complex things, which I don't know how it works, but I know that it's a complex things. But anyway,
there's a product team that knows that.
Yeah, there's a product team that knows that. But they have to consume the whole history, and they had to join with other input streams, and they had to join with other input streams. So overall, this whole joining and then later aggregation translates into a very, very big state. Usually we have this with the Kafka Streams, and it's not a problem really. So we store that much state. But in this particular case, there was the thing was that they wanted to fix their state from time to time. So what this means is that in finance, it's very common to add the correction into your calculations later. So when you in the stream processing, usually when you have a window, this window has some kind of time up until that window closes. When this window closes, you can't really do much about it. So if you send a new event and it doesn't fall into this window, it discards the event. But in the finance, they would love to, what they wanted to do is to do the correction, let's say, few months back, sometimes even like 3 to quarters back in time. That's obviously is a problem, because then you would have to have a window that is that large so it can accept the correction events. But having window that large translates into very, very big state. But alternatively, what one can do with, for example, with Flink, is that when you do want to do correction, you roll back your state to last quarter, for example. You don't have to replay everything in that case, but you can replay only partial stream of events that was for this last quarter, and then you will get your kind of correction events and your aggregation state back to the real-time stream. So this is one of the biggest use cases that we saw where Flink was the kind of had advantage over Kafka Streams.
Gotcha. So in short, you might say a very large job where suddenly the cost of deploying a cluster and the relative friction of deploying a stream processing job to that cluster, and not just a part of your regular application and everything, that's now worth it because of the large amount of state that's associated with the job. But an ordinary microservice wouldn't feel right.
No, definitely not. Because with an ordinary microservice, there are a lot of benefits that we can get from the Kafka Streams, like interactive queries, and we can build. In Flink, there is also like notion of queries, but it's way more complex to reason about it than you would do it with the Kafka Streams, because it's whole clustering framework. But with the Kafka Streams, it's way easier for us to integrate it within our service mesh, essentially, and let the teams also use this way of querying the state.
How is, just a question for you about deployment automation. What's your normal way of deploying a new microservice, and what's it like to deploy, to change a stream processing job in Flink? Compare those two.
Yeah. So we run pretty much everything on Kubernetes. We also run our Kafka clusters on Kubernetes. We recently published a blog post how we migrated from EC2 into the Kubernetes. So mostly we are running like our microservices, also stream processing jobs on Kubernetes. Like the provisioning new Kubernetes deployment is very easy. You just GitHub pull request, it gets merged into the main branch, and then it's kind of creates a whole deployment for you. It's the same for stream processing, but there is of course a but. Since stream processing is a stateful application, we have some other automations around this. For example, like as I said before, we are kind of a library providers and like tooling providers. So we kind of everything that product engineers are doing through our like libraries. And one of the parts of it is also we provide tooling to build the Docker images for like specifically for stream processing. Based when they build those Docker images for product engineers is completely transparent. But when they release those Docker images into the production, they also have the different set of capabilities that they can do from this. Like we have release UI, they can go and like release stuff in production. So there they have additional functionality like reset. And the reset is a very nice feature because they can reset their stream to reconsume the events from the original topics. And so they can reset their state and start reconsuming their stream if they want to deploy a new version of their application, for example.
And that's general Kafka Streams applications and Flink, or just one?
But right now it's mostly Kafka Streams. We are developing self-service for Flink as well to do the same thing.
Any thoughts about? Oh, go ahead.
Yeah, one important note why it's possible is that because we store all the original event streams into compacted topics. So we have pretty much whole history of WISE, of all the core domains stored in the compacted topics. And those stream processing jobs use those topics to rebuild their state when they need. So that means that whenever somebody deploys new version of the stream processing job, they can just set consume this topic from this point in time. Like I want 1 year worth of data, and they will reset in our reset self-service. They will just say, this is the beginning. I want to set my topic offsets to, and then stream processing job will start consuming from that point in time.
Nice. Now I know you're in the money transfer business across countries and currencies, and that's probably slightly regulated, 1 or 2 regulations, right? And that can make the cloud complex. Any thoughts about managed services in the future? Is that a thing that you can think about or not?
Right now, at the moment, I think not, because of the way we implemented security around our Kafka infrastructure. Because we have we have quite unique security setup, because in a way that, and we're kind of proud of it as well, because what we do is that we have integrated Kafka authentication with service mesh, meaning that when service authenticates with Kafka through the mutual TLS, we will get the same identity as the service would be authenticated with other service through RPC call, for example. As a result, we have like dynamic certificate rotations and all this stuff, and it's all like very tightly integrated within our service mesh. So that comes with a cost of having a bit unique setup. It has its benefit, but on the other hand, it also comes with a cost that it's harder to migrate to something else if we ever decide. But so far, it's been working very well.
If you had one word of advice that you could give to somebody who was looking at the same set of problems, a few hundred microservices, maybe some large stateful jobs, what would that advice be? If you had it to do over again and you wanted that to be smoother, what would you say?
I think this, I guess, applies more to the companies that are work within autonomous teams. The mistake that we made in the beginning is that not to delegate ownership of the producing of the source events to the product teams, because we tried to be the team that sources all the events and then replicates it into our streaming Kafka cluster. But obviously that comes with big problems, because we then now have to track all the changes that are happening in the source domains, which is of course not feasible. We have changed this approach a few years ago, where we started to, not a few years ago, sorry, like a year and a half ago, something like that, where we now delegate the ownership of the, when some microservice comes up, for example, and it's a core domain, we are launching new investment product, for example, now. And one of the things that they have to do as well is to produce the stream of events into the streaming Kafka cluster with all the history, so that others can build then necessary stateful processing on top of it. So now we kind of offloaded this to the product team so they can move at their own pace. So I think this figuring out that part of how to deal with the source data and building the proper foundation for this is very crucial, because it enabled us to build so many stream processing jobs just by having all the events into the Kafka cluster, and rebuilding all the stream processing jobs based on that was a huge win. But of course, having a proper foundation of actually sourcing those events into the cluster with the public representation of the domain is very important, and this is was a foundational work.
It sounds data meshy.
Exactly.
Yeah.
We were doing the data mesh before we knew it was a data mesh.
My guest today has been Lavonni Kodretsia. Lavonni, thanks for being a part of Streaming Audio.
Thank you, Tim. Goodbye.
And there you have it. Thanks for listening to this episode. Now, some important details before you go. Streaming Audio is brought to you by Confluent Developer, that's developer.confluent.io, a website dedicated to helping you learn Kafka, Confluent, and everything in the broader event streaming ecosystem. We've got free video courses, a library of event-driven architecture design patterns, executable tutorials covering KSQLDB, Kafka Streams, and core Kafka APIs. There's even an index of episodes of this podcast. So if you take a course on Confluent Developer, you'll have the chance to use Confluent Cloud. When you sign up, use the code PODCAST100 to get an extra $100 of free Confluent Cloud usage. Anyway, as always, I hope this podcast was helpful to you. If you want to discuss it or ask a question, you can always reach out to me at tlberglund on Twitter. That's TLBERGLUND. Or you can leave a comment on the YouTube video if you're watching and not just listening, or reach out in our community Slack or forum. Both are linked in the show notes. And while you're at it, please subscribe to our YouTube channel and to this podcast wherever fine podcasts are sold. And if you subscribe through Apple Podcasts, be sure to leave us a review there. That helps other people discover us, which we think is a good thing. So, thanks for your support, and we'll see you next time.